Today we will start with space lattice. Space lattice is the three-dimensional arrangement of a crystal in space. The space lattice can be compared with a building in which similar type of rooms are combined together to form a big building. The smallest repeating unit of the space lattice is called as unit cell. Just like as in the building a room is repeated unit, similarly the unit cell is the repeated unit of the space lattice. There are two types of unit cell. Depending upon the arrangement of particles, they are of two types. One is simple primitive cubic cells, in which the particles are at the corner of the cube. This is primitive type of space lattice unit cell. Second is non-primitive unit cells. They are of three types. One is body-centered, in which the particles are at the corner and in the center of the body. Second is face-centered. The particles are at the corner and at the center of each face. And third is the end-centered. The particles are at the corner and at the center of end face, that is open face. This is body-centered, in which the particles are at the corner and at the center of the body. This is face-centered, in which the particles are at the corner and at the center of each face. And this is end-centered, in which the particles are at the corner and at the center of end face. Depending upon the parameters of unit cell, the unit cells are of 7 types. They are also called as 7 crystal system. One is cubic, in which all the three sides are equal and all the angles are of 90 degree. Example is NaCl, zinc sulfide, copper, silver, etc. Second is tetragonal, in which two sides are equal but third side is not equal, but all the angles alpha, beta and gamma, they are of 90 degree. Example is white tin and calcium sulfate. Third is orthorhombic, in which all the three sides are different. That is, A is not equal to B, B is not equal to C, but all the angles, they are equal and they are of 90 degree. That is alpha, beta and gamma, they are of 90 degree. Example is rhombic sulfur and potassium nitrate. Fourth is monoclinic, in which all the sides are different. A is not equal to B, B is not equal to C, but two angles alpha and gamma are of 90 degree, but beta is not of 90 degree. The example is monoclinic sulfur and lead chromate. Fifth is triclinic, in which all the three sides are different. A is not equal to B, B is not equal to C, and all the three angles are not equal and they are of not 90 degree. Example is hydrated copper sulfate and potassium dichromate. Sixth is rhombohedral, in which all the three sides and all the three angles are equal but they are not of 90 degree. Example is quartz. And seventh is hexagonal, in which two sides A is equal to B but not equal to C. Two angles are equal, alpha and beta are of 90 degree but gamma is of 120 degree. Example is graphite, zinc oxide, cadmium sulfide and lead iodide.